How it happened? Actually, I started the recording.
When recording started, at corner there is a red, sir.
Okay, so it is coming red.
Yes, sir, now it is.
So now it is.
Okay.
Yes, sir, now it is recording. Sir, when will offline start? Is that
Okay,
it?
so you will be notified.
Sir, please open it after
Actually, sir,
exams,
it is written from April 1st. There will be second semester, and in May they will call us. So there will, in between 1 month, there will be CA3 happening for all of us.
No. There is no CA3. There are only two things, CA1 and CA2, and then end-term examination.
No, sir, I am talking about second semester CA1 because we are giving 1 month of online classes. Then in May there will be offline classes.
Yes, if you know everything, then why you ask me? You know these things. Okay, your second semester, first few days it will be online, and then after that
Yes, sir.
it is supposed to be started.
Focus on the interim examination. Sir, please.
Yes, you have to focus on the interim examination. Try to score as much as possible so that you get a decent mark, because your mathematics paper is of 4 credit, so it is very much vital. Even result is important in the sense that if your score and result is good, then there may be some possibility of change of grade also. Sorry, change of branch.
So how we get credit?
Okay, credit, okay. Suppose mathematics MSc 01, this paper is 4 credit. This is an example. Show how credit points you get. 4 into 10, maximum points is 40. So if you score EX, this grade, EX means 90 greater or equal to 90. So 90 to 100, if your marks out of 100, this is out of 100. So then you will be regarded as EX, your grade is EX, and in that case your points should be 4 into 10 point, that is 40 out of 40, something like 100%. Okay, so if you score 90, then you will get 40 credit points out of 40 CGP, and 40 will be your score, 40 out of 40. So similarly, if it is 80 to 89, then it is it will be 9 into 4. Is 4 into 9. So this is 36 out of 40. In this way it goes on. If it is B, then it is 4 into 8.
Sir,
30.
it is not relative
These
grading.
signs help us to change the branch or any
Don't
shape
we have
also.
relative grading, sir?
What?
Relative
This
grading.
is same for all the subjects.
No, this is a 4 credit subject. If it is 3 credit, then total credit point is 3 into 10, 30. Out of 30, if you score EX, then it is 30. If you score A, 3 into 9, 27, like that. So it depends on the credit allotted for a particular course, particular paper. Okay.
So that means the 90 means 10 CGPA. It will come.
If you have 90 means 10 CGPA for that particular paper. If you score 90 for all the subjects, then your CGPA will be 10 point, full 10 point. In a 10 point scale, you will be getting 10 point.
Sir, has anyone got it before, sir?
This is there. You should know these things. If you do not know, then
Yes,
you can.
Sir,
credit
sir,
is a fixed amount of
sir, the lab numbers, will it help to increase?
Start the class, sir.
Yes. Okay, now I like to solve some questions, or you will be able to solve at your own, because multiple.
No, sir, please start the class.
Yeah, I'm starting.
Sir, in MCQ.
We just have to
Again,
solve the question. But in subjective type question, we have to narrate it.
oh, what you write your answers, you have to always, we prefer to get your answers precisely and brief. It has to be brief and precisely. Don't you have to give the logic for each and every step, but try to write in brief also, both the things.
Thank you, sir.
Okay, sir.
Okay.
Start the class.
So whatever the things it has covered, basically, is it necessary to tell these things? I have started the introduction of basically Newtonian integral and then Riemannian integration, and then how this can be generalized for the double integration and triple integration. And then what is the geometry of double integration, how to evaluate them, and for initially we start with a function to be non-negative, and then non-negative function defined on a particularly rectangular type domain of definition, and then arbitrary domain of definitions, how it can be analytically handled. So these things, it is over, and also whenever your function. Hello, what happened?
Satish, mute your mic.
Okay. Then how to evaluate or how to apply it in that situation, what actually we did. We have taken certain types of region, elementary region. So one such type is elementary region of type 1, another is type 2, another is maybe type 3, which can be written as either type 1 or type 2. And then maybe change of variables, change of order of integration also one of the important thing, where whatever the order it has given initially, so that may be a little bit difficult, but using Puyon's theorem, if we can solve the other order, then it is very easy to, it may be very easy to solve the given integral. So that's the basically main focus of learning change of order of integration. And then the development of triple integration and the geometrical interpretations, and similarly in the parallel way as that of the double integration, we have learned how to just evaluate the triple integration whenever your region of integration is not only it's a cuboid type, like the case whatever rectangular parallelepiped, I can tell. Say for example AB cross CD cross PQ. So in this situation, the situation is a little bit easier, and similarly we can define for the arbitrary region like type 1, type 2 and type 3 region. So how to do that, these things also it has been done. And then another important part in case of multiple integral, change of variables. So initially we have started from Cartesian coordinate to polar coordinate, and then cylindrical coordinate system, then spherical coordinate system, and lastly what we learned, that is basically your arbitrary transformation. Okay, so transformation, arbitrary transformation, it depends on the situation what kind of transformation we have to use. In that situation also, how to basically write instead of dx dy, what could be another factor. So that is basically mod of the Jacobian of the transformation. So that's what we like to actually we learned it, but today I start with some examples of this type of things. Okay, suppose this is a question. First listen, try to read the question. Use change of variables. Here change of variable it is given. It is x is equal to u square minus v square, y is equal to twice uv. We have to evaluate this thing y dx dy, where d is the region bounded by two part of two parabolas. Okay, so what we have to do? So this is the region of integration. You can see this part is y square equal to 4x plus 4 in the left hand side, this part, and right part is y square equal to 4 minus 4x. We have to first draw the picture in order to have some idea what could be the region of integration. And in this case, it is a little bit difficult to predict what could be the change of transformation, change of variable we have to use. So that is why in this particular question, change of variable it is suggested, and the change of variable is u equal to x equal to u square minus v square, y equal to twice uv. This has been suggested. Okay. So what could be the dx dy?
4 into u square plus v square into du dv.
Let uv, sir. Let uv into u square plus v square into du dv.
Yes, sir. J into du dv.
Yes, this is twice u. This is minus twice v. This is twice v, twice u. So it is basically 4 into u square plus v square. Very good. This is greater than 0. Okay. Then I have to be okay. Should I erase this part? Okay, I erase it.
Yes, sir.
This part only I erase because other part it has, if it is there, no problem. So whatever the initial integration, what we have to do, dx dy over that particular region D. So this will be your another region S, and this is twice uv because y is equal to what? You see y is equal to twice uv, and dx dy it will be replaced by
Jacobian du
mod
into
of
du.
the Jacobian of the transformation into du dv, right?
Yes, sir.
Okay, so it is basically it is equal to 0 to 1. If you change it, then your S will be 0 to 1 cross 0 to 1. This is very, very simple. S is a rectangular region, 0 to 1 cross 0 to 1. This is twice uv into u square. 4 is there, 4 into 2, u square plus v square du dv. So here du dv dv du, whatever you can write, it will be same. And this integration is absolutely easy. You can check it. And should I write the answer? I have already calculated it. Its answer is 2.
Sir, why the limit is 0 to 1 here? Can you explain, please?
Okay.
How we are finding the limits?
See, suppose 0 to pi sine x square, x sine x square dx. In this case, what should be the change of variable?
X square.
X square equal to t, right? Then
Yes.
how you find the limit for t?
By
Whenever
substituting x square 0 comma pi square.
Yes. So similar way you have to find the limit for u and v, because you know u and v by the virtue of the transformation. So you cannot find it.
We should just substitute x and y in terms of the two equations. So y square is equal to 4 minus 4x, and we'll get two straight lines. So the limits will get from that.
Very good. Okay, so I think so we can skip to the next question, and that is little bit difficult. Another question, suppose we have to evaluate this thing, x plus y divided by x minus y dx dy. Where this D is basically trapezoidal region with vertices 1, 0, 2, 0, 0 comma minus 2 and 0 comma minus 1, say for example. Now, and this is a trapezoidal region. See, whatever it is given, if we try to integrate it, then it becomes little bit difficult. Why it is difficult? Because of this part. So what? So suggested change of.
Sir, here we assume x plus y as u and x minus y as v.
Sir, we can take x by x minus y as u and y by x minus y as v.
Yes, sir. That would be better, sir, because e per u plus v.
Yes, sir. Second one is better.
So we can take u equal to x plus y and v equal to.
Sir, but then e per u by v is hard, no, sir, to integrate. So what when you take like that?
No.
e to the d into e to the minus g.
Okay. Okay, sir.
Ultimately, it will be easy. You have to check it.
Yes,
so
sir,
that
yes.
means what? X is equal to, in terms of uv, whatever it is. Y is equal to, in terms of uv, minus b, right? So what
Yes,
could be the Jacobian of the transformation? xu, xv, yu, yv. So what is that? That is minus half. Half. So it will be 1 by 4 minus. It is minus half, right?
Yes, sir, minus
1 by 4.
Yes, sir, minus half, sir.
Yes, sir, minus half.
Okay. So
half du dv into e per u by v.
then we have to find the region. Yes.
Yes, sir.
Sir, if we consider x by x minus y equals to u and y by x minus y equals to v, will there be any problem in integrating it?
No, you have to see basically in that situation, Jacobian also important part. If it comes in such a way, then your integration favors, then it is very easy. You can do it. Okay. So I cannot say that this is the only one transformation you have to use on only this transformation. That I cannot say.
Okay.
So if you find something else, that also it can work. So what could be the S?
So one show the region, sir, once in the question. Once, can you go above?
We can write this as a bigger rank minus.
Should I draw the picture?
Once go to the coordinates, the trapezium coordinates.
Okay. Okay, I have to show it. 1020. This thing basically, if I draw it here, then minus 1, minus 2. This thing, right? This is basically your D.
Yes, sir.
And ultimately what it will
X
be
is tending from 0 to 2 and Y will tend from
this is minus 2 comma 2 2 comma 2 and this thing it will be 1 comma 1 and it will be minus 1 comma 1. So this thing a little bit here, this thing is basically your S, this region. This is again a trapezoidal region. And what is the basically this is U equal to V and this is basically U equal to minus V.
Sir, you said 1 comma 0, 2 comma 0, 0 comma minus 2, and 0
You
comma
will
minus
vary
1.
from 1 to 2 and we will vary from 1 to 2.
Yes, sir. 2
yes, sir,
minus.
correct, sir. Because X will vary from 0 to 2 and Y will vary from X minus 1 and X minus 2. So you'll get that.
Minus 2 to 0.
Okay. That means I can write S in terms of this thing U comma V such that 1 less or equal to V less or equal to 2 and minus V is less or equal to U less or equal to V. You see the picture, then you understand it.
Yes, sir.
Yes. Okay. So this is your basically S. Then so ultimately we can get e to the power x plus y divided by x minus y dx dy. It can be over d. It has to be over s, right? So e to the power u by v mod of the Jacobian of the transformation du dv. Okay. So this thing is ultimately 1 to 2 minus
yes, and again 1 to 2.
No, minus
okay,
b to
okay,
v.
Okay, yes, sir. Yes.
E to the power u by v. This will be half because it was minus half, so it's mod. It will be half du dv. Okay, now
Sir,
since
how the limit became from V to minus V, sir?
minus b to v, not v to minus b.
Yes, sir.
You see the picture, then only you understand. U is here.
Yes, sir.
So basically, it has been written in terms of the type. I can say type 1 region, right? 1 to 2. Okay, I write a different color. This is 1, this is 2.
Yes, sir.
And then this is minus b.
Minus V.
This is b.
And it is V.
Okay, so it is. Ultimately, it will be coming.
पेपर ले गया ना
3 by 4 E minus 1 by E.
3 by 4.
Multiply by E minus 1 by E.
Very good. Excellent.
Yes, sir.
Okay. So this is your answer. Okay, in case of triple integration, if I take another exercise, suppose we have to evaluate this triple integration. z into x square plus y square dx dy dz over x square plus y square less or equal to 1 and 2 less or equal to z less or equal to 3. This is little bit simple, but I like to ask all of you, what kind of change of integration, change of variable we have to use here?
Cylindrical transformation.
Cylindrical, sir.
Cylindrical. R theta Z.
Yes, sir. Cylindrical.
Very good. Cylindrical transformation. Why? Because here you see that
the reason is cylinder.
X square plus y square is
Yes, sir. It's a
formula
circle
cylinder.
and Z is stacking.
There are two things. Region is cylinder. Very good. Whoever told. Another thing is that in the integrand function, if you look at, then there is a term x square plus y square. It is there. It is present. So it is advantageous if we use the cylindrical transformation. So what is the transformation?
We will replace x square plus y square by r square.
Y equals to r cos theta. Y equals to z.
Okay. And ultimately in cylindrical coordinate system, what will be your limit? Straight away, I like to write at
0 to 1, 0 to 1,
0 to 1,
0
to 1,
then 0 to 2 pi,
2 to 3,
0 to 2 pi, and 0 to 3.
What
0
minus
2 to 3.
dr d theta dz.
And Jacobian will be R.
yes.
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 Here we have to write it cautiously.
Yes, sir. It should be dr d theta dz, sir.
No, first dz, then d theta.
Okay, yes, yes, dz.
Yes. Dr. Okay, because I put the limit here z to equal 2 to 3, then theta 0 to 2 pi, then r 0 to 1, and then you can do this thing. So what could be the answer?
5 pi by 4.
5 by 4.
5 by 2.
4.
5 pi by 4.
5 pi by 4.
5 pi by 4.
5 pi by 4.
4.
Good. Very good.
5 pi by 4.
Yes, it is coming 5 pi by 4. Okay. So it's fine. And okay, I have just today also, today in the evening I will give the updated lecture note. So from there you can solve some other questions. Then definitely you can answer. I am sure you can answer whatever questions it will be coming.
So if we have any doubt in any question, can we message you?
Definitely. Definitely. Actually,
Sir,
I like it.
Give an example of spherical transformation.
Okay, so whatever you are having the questions, so I first suggest you definitely you have to solve. You have to try at your own for 6 to 7 times, and then you can discuss it with your friends, and then you can search it for more internet and other things. And after that, I prefer that group discussion. If you discuss it in a group, then it will be very, very good. So maybe some other student can solve it immediately, because each one is having some different angle of thought, so that they can get the answer quickly. So after that, still if you are having problem, then definitely you just write in a page, and you can just write it through mail. Okay. So if you need one more lecture before the examination, then also I am ready to give the lecture. It may be it may depend basically across all the particular portions of mathematics 1. So if you like, I can give you. Okay.
Sir, give some question for practice.
Hello, sir.
There are many questions there in the lecture note. I will okay, let me tell you. Today I will upload the revised lecture note also.
Sir, can you solve one problem of spherical coordinates that?
Today?
Yes, sir, today. Like an example, as you gave for cylindrical coordinates.
Even okay. If I give this type of thing, x square plus y square plus z square whole to the power m and dx dy dz, where m is positive over the region v is basically unit sphere x y z such that x square plus y square plus z square is less or equal to 1. Okay, so here m is not necessarily positive integer, it is a positive number. So in this case, you understand that we have to use spherical coordinate system in order to get it very quickly. So what could be the spherical coordinate system? X equal to r.
Like x square plus y square plus z square less than equal to like 2, not instead of 1.
If it is
R
2,
square, right?
then what could be your r?
0 to root 2.
0 to root 2, yes.
Yes. So it is
0 to root 2, sir.
Ultimately r square equal to z, na?
Yes, sir.
Rho will be 0 to root 2, sir.
Rho or r here. You can give rho because I follow rho. Okay.
Yes, sir. Rho will be 0 to root 2.
Yes, sir.
And what will be theta? What will be phi? And what will be your Jacobian? In
0 to 2 pi side.
5 0 to pi.
0 to pi is a pi, sir.
Yes, sir.
One is 0 to 2 pi, another is 0 to pi. This is the full, because your region of integration is the full sphere. So it will be the theta is having the full rotation. That means 0 to 2 pi. And phi is having the half rotation 0 to pi. And I gave the logic phi theta is 0 to 2 pi and phi is 0 to pi. The way we have taken, and if you draw the picture, then it will be clear. Okay, so this is also easy, not difficult. So you can do at your own.
Can you show please the previous example?
Yes, sir.
This example?
E raised to x plus y by x minus y, that one.
Okay. Where is you are having problem?
That limit part, sir.
Minus b to b.
Yes, and 1 to 2 also.
You see this particular what is your
Sir, if we do Baburam for multiple integral, is it enough? Means any book.
What? For double integration, which book you should follow? Let me first tell the answer. Here, what is your v? V is running from 1. What is v here? 1. What is v here? 2. 1 to 2 is particularly v. And u is here. This is a curved line, straight line, inclined. So u is minus v. Here u is v. So I took the limit.
Sir, where are those 0.11, 2, 2, minus 1, 1 and minus 2 plotted from?
Okay, so it is from
That
this.
is changed into u comma v. So the doubt is that how did you get the equation u equals to and u equals minus 2? That we get by putting these u equals x equals to half into u plus v and y equals to half into u minus v in the equations given. You'll get the two
Yes.
line equations and then you can solve.
Just add u and v. You will get 2x.
Ha.
X is u plus v.
Okay. So whatever I like to again repeat that in my lecture note there are many questions, you can solve them, and you can I suggested you to follow the book whatever Marsden, Tromba and Weinstein multivariable calculus. You can follow that book. That is very nicely written book. So there also you can find so many exercises.
Sir, please write the book name in chat box also, sir.
How many times? Earlier also I wrote it. Okay, anyway.
Notes are very
Multivariable calculus.
Okay, I am writing here. By Marsden. Actually, there are three authors. Marsden, it's fine. Marsden, Weinstein, and Tromba.
Sir, is Baburam also okay for multiple integral?
Baburam, it's okay. But you have you can follow the theory from the book, whatever I suggested. For exercise, you can see the book from Baburam and some other books. If you get, then no problem.
Means I want to ask all sorts of problem are covered in Baburam, na? That's my main question.
That I cannot say, but whatever it is necessary, and if you follow my lecture as well as if you follow the lecture note of myself, and obviously bigger part is multivariable calculus, that book, so you can follow those things also.
Okay, sir. Thank you, sir.
Thank you all. I think this much for today. And
Hello, sir.
If you have any problem, you can send me. Okay, I'd like to.
Hello, sir.
Sir.
Hello, sir. Sir, can you please